Should we start? जेवण बरं शिल्ले नाही आम्ही रानून नाही शिल्ले डिझाईन फॉर चेंज पण सांगता येत नाही आपण हे आणला ते So let us keep the clear command which is there will computation. So आम्ही किती करता पहिले आम्ही कशे म्हणताले let's say there are two things over here for us to do. Recording केले चालू to do earlier is, let me just move this a bit up so you can see it here. Let us say something like def is 100, right? So def 100, and we used to say this is 100, correct? And then maybe 150. Is equal to 100 plus 50, right? And then we will say println 150. Correct? See, you can see that. Sorry, just 50, right? 50. You can see the output here is 150. Also code सगळ्यांनी पाहिला ना आमचा स्टँडर्ड कोड आणि आता आम्ही चित्रा काढतात. How is that code related to this form? We can see that there is a mathematics happening here. We see some kind of computation happening here. But when we were trying to draw birds and everything, where was the computation? Without knowing this, a lot of parents, even teachers can get confused. And that is true to a great extent. That was true because in Turtle it was just turn left and right. Let me show you something. This plus 100, right, plus 50 that you see here is like a sugar coating. Actually, I'll do something, okay? Try and see. I'll say 100 dot. Okay, control space. And if you see, there is plus there. Right? And I can actually now say 50. And this will work. See, 150. So that directly plus, right, was essentially saying call this plus on 100 with 50 as a parameter. Get it? Now I'll start changing this and it will actually turn into drawing the same thing. This is the first step I took. What I'm going to do here in case of this 100 is I'm going to say picture dot circle, right? Then instead of this plus, what should I say? Or even I can say ellipse. Ellipse, right? So I'll need to give 2. So maybe I'll say 100 and I'll say 50. 50 here. So I'll remove this. Okay. Here I'll say that's rotated by the same 50. Correct? So instead of dot plus, I said dot that's rotated. And here instead of println, I'll say draw. There you go. Is the computation clear? What we used to do with numbers, we are doing it with shapes. That's it. whenever you used to say plus something or something, that's nothing but it's a shortcut for this dot plus. I mean, very well write some function saying it's plus. That's completely possible, right? So I took a arithmetic and converted that into a shape. Now this is how it is related. Okay. Everyone clear at this point? Where? Yeah, here also you could have put it. I showed that as an example. There was a previous example here where you will say this is 100 and this is 100 plus. So essentially, this was the way we did it. Oops. Pictures. No, did I lose it? Ah, yeah. No. I think I should just say open. Yeah. So clear. I'll do it again. Okay. So let's say if I have something called as 100 and then 150 is equal to 100 plus 50, and then we'll do println 150, right? So this here we can clearly see there is a computation going on. The problem is when we say we are showing drawing, right? People don't see where is the computation going on. So how do we go from here till that point? So this is printing it here. How can we convert this to a drawing? Is this plus is actually a short for dot plus and this going in a bracket. Right? And then I can convert this to picture dot picture dot ellipse 100 comma 50, and this becomes that's rotated, and this becomes draw. So when you are writing it, right, you see how it is like modifying it. 100 is still ellipse. If I say draw 100, it's still ellipse, right? 150 is at 100 rotated by 50. Correct? So this reading, the way you end up reading it, right, is important. So let us try doing the same thing in another way. Is this okay? Has anyone noticed we are not using variables? Hundred is an ellipse of x-axis 100 and y-50. We'll talk about that. Variable is an entirely different concept. However, no, but you'll see the oddity of it. Why we are avoiding it is important. Rather than saying variables is bad, the question should be why we avoid it. So you can always go in the wrong lane, right? But why we avoid going in the wrong lane is a more rather topic. Okay. So let's talk about reading things out. Okay. I'll say def circle is, don't call it equal to. Okay. This is not equal to. Thing is, the way to read it, circle is a circle of radius, let's say 100 or 50, right? Circle is a circle of radius 50. Then ellipse is a circle that's scaled by scaled twice on the x-axis as compared to the y-axis. So if I now try and draw it, correct? And circle is a circle. Is that correct? The reading is important. Where we say circle, doesn't like me coming near it. Circle is a picture of circle is a circle of radius 50. Ellipse is a circle that's scaled by twice the value on the x-axis as compared to the y-axis. So this is rather that equal to symbol that you see, right, is short for ease. So now you see why it's named that way. Because you are reading it. Ellipse is a circle that's scaled. It will become a bigger circle, but then it is not going to be ellipse. So similarly, can we build further? Can we say def vertical ellipse is an ellipse? Is an ellipse that's rotated, right? That's rotated by 90. And if I try to do vertical ellipse, this reading is important. So when you name something as P1, D1, it loses the meaning. So if you're drawing a butterfly, your depth should be wings, this face, something like that, right? Rather than shape 1, shape 2. If you do 1, 2, it will be exactly this. So if I say 1, 2 here, it will rotate there. So try it out. So either way. Make sense? So a quick topic on why we were avoiding variables. हे झालं नाही सगळ्यांचे? लागी सुद्धा उचलू ना. Let us do it. I'll remove this. Think. This is better. So there is something called as a name given to it, and then there is something called as a box. Okay. What is the name given to it? Her name is Sonal. So Sonal is not a separate entity. You know, she is Sonal. It's not like I have created a box called Sonal and put Sonal in. So there is something called as a name. Why we always don't want to say, you know, that teacher. So we'll say Sonal teacher. Because that teacher has a problem. If I am there, then that teacher may mean some other teacher. But Sonal teacher will always be she, no matter where I am, correct? So we give a name to things. Right? Maybe this is a bottle. Something like Manjusha teacher's laptop. It's a name to it. Not saying to laptop re, to re also lamashlo yashlo. The teacher bashilli. Doesn't happen that way, right? So it's a name given to it, which essentially means the moment that name is given, right, you see that person in front of you. Similarly, let us try and do this, right? Def. Okay. 1 is, let's say 1. 2 is, let's say 2. And def 3, I'll say it is 2 plus 1. Correct? And I can like print it. Or the best thing is I can actually run it in a worksheet mode. Not this, sorry. Where did that? Yeah, worksheet. So there. So if I have to see the values of this, I'll say println. And I'll say 3. And there, 3. It's here. So I've got 3. That is fine. The problem, the thing is, instead of this 2, I could have very well said 1 plus 1. The output still comes as 3. Correct? Or here, I could have just said 1 plus 1. Like this. And the output is still 3. Or here I could have simply said 1 plus 1 like this. And then here just 1. And the output is still 3. What I was trying to say is when I was saying 2 here, it was always 1 plus 1. We just had given 1 plus 1 a name, that is 2. Correct? Because we want to group things, right? तू कितले बनाना खाले? एक खाले, मगर आणि एक खाले, मगर आणि एक खाले, मगर आणि एक खाले. तू समजून घ्या आता किती. कितले बनाना एका वेळा कोण खाता हांव नको. So that is what exactly it means. It's a name given to it, but at the same time, right? It's actually counting. So the 3 means I have actually counted to 1 plus 1. Now, this is a very, very important concept. Why is that an important concept? Because there is a concept called as infinity. Okay. Then people confuse infinity. What is infinity minus infinity? You cannot calculate it. See, for that infinity to occur, right? See, 2 minus 2 means what? I have done 2 steps. So I have to first do the 2 steps, and then I have to do 2 steps in the previous direction. Then where I am is 0. The problem is infinity is your first infinity will never happen. For it to become an infinity, you should not stop. So if you are not stopped, how will you come behind? Right? That is the whole point. You cannot stop. So your first infinity itself will not happen. You cannot remove infinity from it. Infinity is not a number. Similarly, something divided by 0, what is the value? Correct. It's not defined. People generally don't get it. They generally see, oh, there is something 0 here, something 0 here, 0, 0 cancels each other. You can't. It's an operation itself that is not possible. It's mathematically not possible. So something that is not possible cannot be done. Right? So it's same like that. But the moment we give a name, right, and that name becomes a box, something out of the world happens. Completely out of the thing. If infinity was a name given to a box, I can say I kept a box, I removed a box. So infinity minus infinity achieved. But it is not possible. There is even a bigger problem. So Scala is like a middle ground. There are languages which completely say no variables. And there are languages which say only variables. Scratch was one example, right? And then there are languages which take a middle ground. Let's say, let's give variables, but let people decide not to use. It's like there are some countries which will build a road, right? Left lane and right lane. And in between that, there is an ocean. Some countries will say, okay, you know what? Let's build a lane, but let's mark it. Let people decide, like, which side to go. Bad things happen. So let us see one weird issue that happens when variable comes into picture. Okay. How do we define variables in Scala? Where? Okay. So I say where x is equal to 1. Now I need to get 2. Okay. I'll say x is equal to x plus 1. Correct. This gives you 2. It does give me 2. Right. And we teach them like this. Anyone noticed a problem? Forget that. This is a very, very weird statement. Anybody who has not learned C programming and has learned mathematics properly, right, will see or notice problem there. No, they always do that. X and x on both sides, x cancels each other, 1 is equal to 0. This is the problem because of variables. It is not that simple. Even bigger issue is variable is a box. We never do that here. In real life, you don't put somebody in the box and ship the box. Right? Go and talk to Venkatesh sir. Or do I say, okay, take a box, put Venkatesh sir in it, and tell you go open the box and then talk to the person inside the box? It doesn't happen that way, right? It's not real life. You cannot relate it. If you artificially try to relate it, that's where the problem happens. This is a box. This is the value inside the box. Just because they are on different sides, they have a different meaning. In real life, this sounds so complicated, right? Create a box called Venkatesh. Okay, put Venkatesh in it. I have to talk to Venkatesh. So I stay outside the box and then talk to Venkatesh, which is the box. In real life, anybody walking into the Kop mallare. How do I know when to open the box? So that's the question. Okay. It becomes very clear. One, if I say this is well, moment I say this is well, compiler itself will tell me something is wrong. Correct? Or for that matter, I can even convert this to def. Both are possible. This is not possible here. So you can choose either between def or a well. Both are fine. Right? In definition of Scala, no, I can use this many number of times. Whatever you can do with def, you can do with well. Slightly differently, but whatever you can do with def, you can do it with well. I'll give an example, right? So let me create a function that adds two numbers. So I'll say def add x colon long y colon long, and this gives me a long, and then I'll say x plus y. Correct? And I can then say println add 2 plus 3. Sorry, not 2 plus 3, sorry, comma. Yeah, so there is 5 there. I'll clear this so it will come on top. There is 5 there. Now this is not there for the students, okay? I'm just showing why this is the case. How do we make the same thing if there is a well here? If I write this well there, it will fail. Right? Because I cannot define a well like this. Well has to be a value. But I still want to make it a function. There are many ways of doing it. One simplest way of doing it is x and y here, right? So I'll simply say I need one long here and another long here. And this works. Fine. Same thing. There is no difference between that def and this well. Works the same way. Right? So, and in that reference also, right? If you might have noticed, right? So if let's say this was a well, let's say this was a well, and this well was 2 def, sorry, println 2. It prints 2. And even if I convert this to def, it will still print 2. I don't have to like literally put. Size sir AC. 1. I think that one is on. Yeah. तुमचेरूच नेम धरून असा that one is on. Define. And val is value. Where is variable? सगळीकडे where, well, सगळीकडे. It's same. Where basically creates a box. In that box, you can put something else. Define. right? So good enough. So what we are really trying to do, right, is we are trying to bring mathematics into real life. And when we say real life, right, things has to work as if they are real life. If you, in real life, you don't put somebody in a box. That is why we don't use variables. Now, there was also this topic about loops. Why we avoided loops? Okay, so the big problem of loop is, apart from all that we discussed, right, how they are non-natural. One big problem now we can talk here, it didn't make sense in Kojo that time because you couldn't escape it. Sorry, in Scratch. One big problem with loops is it forces you to use variables. It always forces you to use variables. Let's say if you had to draw that shape, right, where ever increasing size was there, you had to use a variable if you're using a loop. Correct? And that variable basically creates a problem. You have to always look somewhere outside the code, outside that loop where that variable is defined. And that's confusing sometimes when you are reading it. But when we are defining things as a recursion, we used to keep everything close. Forcibly, all the values used to be there in the parameters right there. Correct? Plus, we had more control how things would work. Now, Kojo has something called as a repeat block. Okay, let's take a quick look at that. Let's talk about set speed. Super fast. Okay, and let's quickly draw a picture. So how do we draw a square? You say forward. Let's say 200 and then right. Correct? And then you say repeat. Repeat 4 times and put this in a bracket. And this, sorry, this works. Okay. How many of you see a recursion here? In Scratch, was it a recursion? Repeat wasn't a recursion, right? It wasn't. But do you see a recursion here? To see a recursion here, right? Let's write our own repeat. Or let us say, again, this is not for students, okay? And if you don't get it, that is fine. I want to show you that there is a recursion here. Okay. So let's write this code with recursion. How will I write this code with recursion? And there is this is the topic I'm taking today because every student has a different way of doing it. Scratch made something possible with its drag and drop thing. Okay. But let's say if this was a very simple code, right? To draw a square. Let's draw the same thing by using recursions, explicit recursions. How would that look? Def square, correct? Correct. So what I'm going to say here is steps, correct? Long. And this does unit. And I'm going to say if steps is equal to 0, don't do anything else. Forward steps, sorry, forward 200, correct? Right. And then square steps -1. And no, this doesn't execute because I have to call it. And I have to say square 4. And yeah, now it draws a square. Did I made it complicated? Yes, I did. See, this is, so there is always like a tool, right? And you have a choice of tools with you. You have a choice of concepts with you. Something that can be done with a Pythagoras theorem, no, I want to use trigonometry. And for no reason. Right? If there is a right angle triangle there, and if I know the sides, I can very well use a Pythagoras theorem. I don't have to use trigonometry there. So how is this similar to that code that we did? So sometimes the tools that we use, right, allow us to simplify things. For example, I just want to repeat something these many times. Why should I show somebody this and this? It becomes explicitly more clear if I somehow hide this rest of the details and only say do only this part, right? So let us try doing that. Okay, we'll write our own repeat using these steps. And this is what the power is. It is, believe me, like possibly kids will not get it, but that is fine. Or I'm just showing it here. So teachers don't go back with some confusion. Okay. So I'll say def my repeat. My repeat. It's not the repeat given by Ellipse, it's my repeat. And obviously we have count. That's going to be long. And it's going to take one more parameter, which is what to do. Right? So action, I'll say. This action is a function, okay, that takes nothing and returns unit. Forget it for now, okay? And obviously this returns unit. Exactly the same structure, just one more extra parameter. Okay? Don't worry about this. Don't focus on writing this up. So what this does is I'm going to copy whatever I've done here, right? There. And see how that works. Okay, if steps is equal, if count is equal to 0, don't do anything. Else I'll remove this and I'll say execute the action. Okay, and then my repeat count -1. And then let us try and use this. I'll say my repeat, correct? Count is 4. And instead of this action here, I'll write it like this. And I'll say forward 100, right. And if I run this, where? No, it's saying something, not enough arguments for the method. Ah. No, it's not, I think compiled for that step. I'll simply put this inside. Did I do something weird? Oh, where is there is equal to, right? Which one here? If here? Actually, it's not required. Not enough arguments. Yeah, so what is saying? So required found unit. Where? Here? 5. This is correct. That is correct. It's not giving an error there. It's saying something else. It's saying this right. Yeah, it's saying no, it's not comma. I think I sorry. No. This was the problem. Expected, but space. Yeah. Oh shit. It was my problem all the time. So unit does not take parameters. So yeah. No, I think where? ये वो कैसा? Not enough. Where? Or should I just do it this way? No. Unspecified this. Oh, sorry. Yeah. This should be. Yeah, there you go. Yeah. So repeat it 4 times and you are there. Syntax confusion doesn't matter. What I wanted to show is this my repeat is exactly like that repeat, but internally it uses recursion. See, notice the recursion here. So what Kojo has done is it has taken this, converted it into the repeat block, and provided that to us. So I don't have to write all this mess with me. And if you want to do something using a variable, then that option also exists, but we will see that, right? How to go about. But essentially, I remove this. I remove this my, and everything works just the way it is. Yeah. We can do this. We can. But I'll tell you the problem. This repeat does not return something. Because it does not return something, this one you cannot use with pictures. You can't. With pictures, you need to return something. There are other shortcuts which tend to do this, but we will see. But essentially, we can look into that, but all those shortcuts, right, eventually result into more keywords. So if the students know how to use recursions, they are good for most of the part. They don't need to study a lot of keywords. The only advantage this gives is it simplifies it, right? But we'll definitely see more about it while it's happening. At some places, right, it tends to give you a focus. You tend to see much more clearly that this gets, what happens here is these two things get repeated 4 times. And this sort of gives an extraordinary power sometimes when you're doing something, right? Let us see some example. Have you seen Codex? Oh, great. That's it. There are how many? Well, Lalit sir should call me and say you crashed the server. ICT, ICT is actually what? What is that? Rail booking. IRCTC. That actually gets crashed more often. So let us look at something. How about this? How big is this code? No, not that many repeats. These are actually created by kids. And see there, those are kids. That's it. This is the code. If I try and like copy and paste this, right, it is just going to work. So I can copy the code here, go here, paste, and run. There. Pretty interesting ideas, right? Obviously, it is complicated to read. Can you tell me who's drawing the outer flower, who's drawing the inner flower? Confusing, right? And because it becomes confusing, the biggest problem is by mistake you sort of you say, oh, I want to move this line somewhere else. I move it here and boom. It's not even like one petal missing. It's like something else. So this, what was the problem? I moved only one line. It didn't take away one petal. It took away like literally. And not even like, just one petal did something else. It just converted this whole thing into a circle because of one line. This is called as an imperative programming. Imperative programming means be a hunter, take a ruler in the hand and say, don't think, do as I say. First, stand up. Second, open your book. Third, go to page 5. Fourth, read the paragraph 4. The student says, sir, I could have opened the book while sitting also and then stood up and read. And no, if you open the book first before you stood up, Russia is going to drop the nuclear bomb. That's exactly what happens here. The ordering becomes so much important. It has to be followed in that order. You have to say I, sir. And then there is no rule. So you end up by hearting the steps. And that is why we try and avoid imperativeness in the code, right? Pictures take away the imperativeness in the code. Doesn't matter in which order you try and define something. It will always look that way. The other big problem over here, right, is this repeat thing itself. Obviously, I couldn't have just said, no, do those things 110 times, copy paste, and like make it readable. But the basic confusion is here. That's not it. What if we just change this line and move it from here? Let's say remove this whole line, right, and put it somewhere here. What happened? New pattern. You see that? So this effect, this change had a little effect. That change had a big effect. एक दिवाळीचा bomb, दुसरा nuclear bomb. Depends on which line you are moving. You have no control. Somebody somewhere will press a button. तो गावातलो भुरगो असतलो ना रशियातलो पुतीन असतलो. So ताणे ती एक लाईन मूव केली, म्हाका आवडूंक ना. चल युक्रेनाचेर वॉर करूया. That's how dictators work, right? ह्याचे जेवण बरें नाशिल्ले. चल युद्ध करूया. बायल आयकना. बिडेनाक फोन करूया आणि ताका धमकावया. This is generally what dictators do, right? So imperative programming is more like that. You don't know where things will happen. And so always be careful. So can we sort of make this proper? Right, is the question. Can we improvise on this? Maybe we can, right? I can actually put this in a picture. Correct? I can rather say, see the other problem, right? Did you notice this? Again, there is an imperativeness. What about the save post? Yeah, it is save position and heading. If I sort of remove these two lines, right? Doesn't have a difference. See, did it make a difference? No, it did. It didn't make any difference, right? Then there is left hop, left hop. Is this required? Why is it required? Can you imagine what these two lines will be doing at the end of it? It's very difficult to imagine where this will be occurring, right? The biggest problem is I don't know where the turtle will be at the end of it. That is my biggest headache. I have to execute, see where the turtle is, and then decide something. What happens? That's what happens. Virus like that. So sort of can we make this slightly better is like a question, right? And let's attempt to do that. What I'm going to do is I am going to put this in a picture. Now, what is the advantage of a picture? Everything stays at the center. Everything stays at the center. The moment you see that there is a picture ending, you can tell your mind, this is where things are at the center. Okay. So what I'm going to do is first let's indent this properly. Step 1. Let us indent this properly. And let us indent this part also properly. Okay. Good enough? Next. Oh, that virus is still there. Yeah, we'll remove the virus. Okay. We'll move the virus in the center. So we'll see how we do that without even saying that post, restore, and all that thing. The problem is you have to really calculate where you are going to save and where we are going to restore. Don't want to go there. Let's make it easy. So I'm going to say def. Well, up to you. Preferably def. Def is safest, right? Def. What is this? Petals, right? Petals. And I'll say picture. And put curly brackets. And move everything inside those curly brackets. Okay. Everything went inside a curly bracket. Now it's very powerful. It doesn't draw anything. Obviously, I didn't call it. Let's try to do the other part also. I'll do the same thing. I'll say inner flower. Again, picture. And I'll move this inside. Especially look at the indentations, okay? It makes it easy to read a code. Yeah. Well, done? Now nothing gets drawn. Yes. So towards the end, I'll simply say, doesn't matter towards the end. So this is one big difference between well and def. I did not go down to call it. I can very well call them here. I'll say petals dot draw and inner flower dot draw. Now what is the problem? Yeah, it is not there at the center, right? So simply I will say where I'm drawing the petals, right? I'll say draw center. Because you'll see how he was drawing it. If I put a turtle there, right, you will see how it was drawing it. Yeah, there. Correct. So I'm drawing that now in the center, and now this by default goes in the center. So there was a reason why he was saying hop, 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 hop. Right? So we got rid of that restore and everything. And to a great extent, doesn't matter. I can do this afterwards also. Yeah, works. Orders don't matter. At some places it do, like what's happening inside it. But I know this cannot come outside. Even if I move something outside, right, something interesting will happen. Let's say what, I had taken this right off, right? At least it maintained the pattern. In the earlier case, there was a circle there, somewhere on the right side, not even controlled. So at least it is there. So what about the color? What about the color here? Now the big problem is I have petals, but let's say if I want to draw more than one petal, right? Like, more than one flowers around with different colors. Do I go and change here? All right. So the simplest thing I could do is maybe, let's give it a try. I'll say dot that's filled with and put this, move this whole thing out. Or I can completely leave it and move this here. Pattern changed. Yes, the pattern changed. But that also we can do by other means. I can change the color in which it is drawing the border. So what it was doing was, after every shape, right, it was imperative programming. I just tapped. Can we do something similar thing here? Over here, right? So here, let's remove this and say set, sorry, that's stroke colored brown, and that's stroke sized 5, right? Now it's also filling the color inside. That's one thing that is happening. So now we'll have to sort of draw this afterwards. There. But you can see the name. Petal is a picture where these commands are rotated. Inner flower is a picture where this command is rotated. And if I can put this in a pick stack and rotate them or draw them wherever I want. Doesn't matter. I just wanted to know teachers why this. Actually, it doesn't matter. If they are comfortable, see, if you have actually not said do not use, like a lot of kids are still using repeat. We just tell them go towards recursion. We just tell them that there is a recursion hidden inside. It's magic. There it was no magic. There was no way they could have seen the recursion. Plus, it would have by default forced you into variables. And once you tell them about variables and loops, then you cannot escape it. Once variables enter, that means even maths is interval. X is equal to x plus 1. I'll actually forward a video later where there was actually a research why, and he was actually arguing, do not teach kids programming. He's a math professor. And he actually realized that because we are teaching them programming, they were actually getting confused on maths. Because this concept of box doesn't exist. It exists only inside a computer. Okay. Yeah. Should we quickly do animations? We'll quickly animate this so that there is one wow factor today. So how we used to animate, everyone remembers? To animate or to rotate this, we have to continuously increase the angle. Let's say we start with the angle 0. We increase the angle 1, 2, 3, 4, correct? So we have one angle that is given to us through which we need to rotate. And then we need to tell the next angle. If we don't increase the angle, what will happen? It will always turn by that. It's an absolute value, right? That's rotated 10. Means it is 10. We have to increase the angle. So once this is done, we'll quickly animate this. There are still two problems in the code, and we generally talk about those. Can you identify the problem? Without executing, which color is this and which color is this? What do you expect students to do? Mix the colors in the mind? It's confusing, right? We don't know what it is being filled with. So generally, yes. Def, that I think outside is dark brown, right? Dark brown. And get here, dark brown. And this one is yellow. Petal color or what? Yellow, dark yellow. So now it's readable. Mm-hmm. Color where is? What will happen if I change this to well? Will it work? Yeah. Imperative. Now wait. So I just converted to well. Oops. What happened? Why? So I called defs to be safer, right? This was the reason behind it. The problem is everything that is in well, right, has to be defined before it is used. But if it is def, you can move them anywhere. Naming, indentations. Oh, yeah, yeah. Yes. Centered. Yeah. But once you draw it, it is no more a picture. Draw it. See, this one, draw centered, it's no longer a picture. Once drawn, it's not a picture. Once drawn, it is printed. So before that, this part is a picture. I can rotate this part. Completely fine. Without what put I name? Where was 26, line 26. 26. Oh, block close down. हांगा सुरू झाला न्हू. स्वादानुसार झालं. That is because there is a set fill color here. If you remove it, it will work. There is a set fill color there. So picture allows you to take your turtle graphics and convert it into a picture that you can move around. Whole thing as one unit. Remember when we used to do competitions, right? One of the rule was do not use go to XY. Why? What used to happen? Absolutes was not the problem. It was doing something bad. So the moment you say go to XY and try and draw a line, right? I cannot rotate the picture. I cannot rotate the picture. I cannot make it big. Once you say go to that point, it is done. Now we can. Say go to put it in a picture, rotate kar, whatever. Make what? No, pen drive. Done. Animate करिया. हाँ. Which one? Here. Stroke color. Stroke is the border. So color of the border and the size of the border. Here, these ones, right? So the size is 5. We will make it. Those lines will be thicker. Try and always follow the indentations. Okay. So this line also has a problem. If I start writing this, right, I'm going to face issues. How do I know how many brackets to close? Correct? A rather correct approach. Look at the steps. Okay. I'll say draw centered, and not directly type. I'll expand this. I'll expand the brackets. Right? One bracket right after the name, one bracket below. And then I'm going to indent over here and then type. What's next? So it's coming as petals. Petals dot same thing basically. Whatever I have from here till here. And then I don't need this. Some good habits. Always expand the brackets so that you can clearly see and indent. So I know this bracket is ending here. If there is one more, I'll do the same thing. But always put both the brackets first and then start writing inside. That is happening because because the way it draws. So even though, see, the way it starts, right, turns towards left. There is a turtle here. Instead of this, let me say there is I here. The way it draws, forget about let's say just draw. Right? See the turtle which is there here, right? What is happening is, see, the way this works. Putin didn't like it. So there is a turtle here. Turtle is at the center. But see, this circle is not drawn from the center. What is happening is, see there, it's turning towards left. And after turning towards left, what is it trying to do? It's trying to turn right on 130. So it's turning like this and it's trying to draw this. So this is not happening from the center. That is the problem. Yes, this comes from the center. This petal is from the center, not this. It calculates the bounds and then puts that in the center. So there is a bound of this picture. Inner flower is correct. So the whole picture, right? It sees that there is a rectangle which puts this shape, but that rectangle has more side on the left. If you're drawing both, everything will come in the center. If you're saying draw centered. If I put this in a pick stack, then there will be a problem. But we'll come to that. Right? Okay, let's animate it. Animation requires two things. Obviously, I can easily rotate it. That's not a problem. How do I rotate it? Easy, right? See what I'm doing, okay? I'm using indentations here. So I know it is a petal that's filled with, and now I can easily say dot that's rotated. That's rotated, let's say 10. And this thing will be rotated by 10. You won't possibly see it. Right? Maybe if I don't clear it, it might be more explicitly visible. So if I try and rotate it by say 20 now, it would somewhat come on the previous one. See? Now it became something else only. So I can just draw it twice and it becomes something else over there. Exploration. So it does rotate. Okay. Now what we want to do is this value can start from 0, can become 1, 2, 3, 4. An angle can keep on increasing and it will keep on rotating. Okay. So how do we make that possible? So here is the structure. Okay, take a look at the structure. Okay, let me put some value here, 0. The block that we need to use here is animate. Animate with state. Why do we need a state? What is a state? State is the angle. Anything that is going to change becomes a state. Okay, animate with state. See what it is trying to do. Okay, it's asking me, see, variables are not required. It's asking me which value should I start with. Which value should we start with for angle? 0, right? So this value comes in this S. Okay, and I can copy both these things there. Now, and before doing this, do not forget to erase pictures. Okay, and then that's rotated S. S. Now, do you think this should work? So the error it is trying to say is I didn't tell him what is the next angle. So what I'll say is return the same angle again. Angle that I received, return the same thing. What will happen? I didn't change the angle. It has drawn it. It won't rotate. But if I say angle, that this value, right? S plus 1. S is that angle. It's becoming a bit heavy. Why is it becoming a bit heavy? Turtle graphics. Turtle graphics is quite heavy. It's like trying to draw those 110 times, right? Internally, and that's becoming a problem for it. Yes, yes, yes. All that is possible. But you can see that. And secondly, it is draw centered, right? What if it was not draw centered? Would that help? Would that make it faster? It's still not. So picture graphics, because the whole turtle is trying to move inside, right? Becomes like extremely slow. Can we make it super fast? Will that help? No, still quite slow. This is a very heavy picture. for it to like continuously draw. If you have used any video editing tool, right? If you try to export it, every screen takes something like this. So you see, like, CPU is trying to run hard. So maybe we draw the outer flower as is. We keep the outer flower as is. What if we try to rotate the inner flower instead? Would this work? And just animate the inner one? I'm not sure. I'm not sure. Will this work? Ah, that's rotated. I'll remove this that's rotated from here and maybe put it here. Not sure what will happen. It might just take away the entire. See, that one is rotating now. That one is little lighter on its behavior. So one reason where pictures are more efficient in drawing things is that they are fast. Can we draw a similar petal using pictures? सांभाळून येऊच्या पटकन ना स्क्रीन होता. Yeah. It's creating a very interesting pattern. Where? Positive angles. Protractor. In protractor, the angle increase counterclockwise. So just say negative. If you say minus S, it will go on the other side. You can try that out. If I just say minus S here, and it will start going the other side. Up. I'll say angle. There. Zero. Meta. You can draw given picture also if you want. Titlets erase करपाक मेळटा. सेव्ह करा तुम्ही. अपलोडेड. टीचरीन केले सुद्धा कितें. कशें में?
We draw and draw कोई petals असा.
हाँ.
ते after animated state जाल्ले तर ते येना.
No, animate. You cannot go after animate. You can never go after animate. If you put anything after animate, right, it won't get executed.
Correct. That is what I did.
Because animate continues to run. Break it. Line 3. 31. What is 731? Something must be. This error is showing here. Animate. It will draw. So put a bracket. Some bracket. Oh, no. Draw center. Okay. 31 1. No. It is a 31? Yes. Title. Color. Animate with draw. No, it's animate with state. Animate with state. Function use. I'll come. I draw centered method. In the animate. State. No. You say draw centered. Inside that you put petals dot dex rotate. Yes. Correct.
Inside that small that this coronavirus, some comment. I just commented this part only.
Yes.
There is some error.
No, because you have selected it. It's trying to run the commented code. Uncomment. I mean, just click anywhere else. Now. Now. What happened? Ma'am? Ah. Erase picture. Yes. In the current one, yes, that method, because it doesn't know which picture to click. Clears all. Oh, okay. Time for tea. One gradients once more. Now, fine. Different. This is RGB. Hmm? Fifty longer. This has to be 50. None. So Sai sir gave a very good feedback that 110 was not required. It was by, okay, so it was a pass-on message. No credits to Sai sir. There. Oh, that's difficult. Where? Sorry. Right? First right is 130. This one, make it 60. And 120 or 20. 160 and 160. तो क्या क्यों नहीं हुई? उधर हांव सेव करपाक विसरिल्लो. Not working? येता येता. Where? Yes. Is S plus 0.5.
Plus.
Yes. That is the next value. No, that's fine. I reached here. So animate its state as 0 depth. But essentially saying oh, I think the problem must be here. So maybe nah, in the clear mode, it could be this one is confusing. But expecting a bracket to end, some bracket. Limit would say patterns. Oh, this is correct. This is ending here. Then we are saying S plus 0.5. Oh, wait. Sorry. Ah, it's just to close it. So can we close here? We can. It's not the problem. If let's say this line is not there, then everything is fine. Ah, here, man. Color has one more extra bracket. Yes. That was the problem. Now it's simply saying that this was. Yeah. So 0, you cannot add 0 to 0.5. I mean, it's long value, like 1, 2, 3, 4, they are not decimal numbers. So you cannot add to a number that has a decimal point in it. No, break. Extra bracket actually. So ते सांगतालो की तो close जाऊना म्हणून. ते close जायना म्हणतालो तो. डोळे